we're going to look to see where our x-intercepts fall. So by clicking on the graph, it looks like this is around at -4, 0. There's going to be a pass, a bounce at 0, and there's going to be a pass through 5. Okay, so let's go ahead and write that equation. So f of x equals x plus 4 passes through a bounce at 0. So I'm going to put that x squared raised to the x squared. And then it will pass through the point 5, it looks like. So x minus 5. And also the x squared, it doesn't matter the order in which you write the factors. I will put this in the front. So x squared here in the front. Now we don't quite have our a value, so we need to calculate that just like we calculated in the other examples. We want to find our a value. So you could kind of guess and check, or you can use algebra. So we want to find some value in the front. So you could see the red graph, which is the one I have written here. We want to match it with the blue graph. So if you somehow made it a little wider, perhaps, you can guess and check. Let's say I put the number 0.5. So that looks like it's just a little bit too wide. How about 0.7? Almost. 0.6? Not quite. Maybe 0.75? No. So we could guess and check, or we can just go ahead and choose any point on this graph. So it looks like there's a point here, 2, -48. Okay, so I am going to try to rewrite the equation here. So let me first copy it down. Sum a value times x squared times x plus 4 times x minus 5, and we will choose this point, which is 2, -48. So 2, -48. Okay, let's go ahead and see what that looks like on paper. All right, so if you recall, this here is my x value and this is my y. So if I plug these values into x and y, I can calculate my a. So plugging it in, I have -48 for this one here is equal to a. My x is 2, so that will be 2 squared, which is 4. 2 plus 4 here, which will be 6. And 2 minus 5 here will be -3. Now we have -48 is equal to a times 4 times 6 times -3. So basically, we're just going to multiply that out. 24 times -3 is -72. We will divide both sides by -72. And we have a equals to 48 over 72. Of course, you can reduce that. So if you enter it into Desmos the way you see it, it should be just fine. So that is 2/3. So let's go ahead and see if we got the correct a value by plugging it into our graph. So 2/3, I'm going to put that in the front. That means 2 divided by 3, and that will work. All right, let's go ahead and look at the next one. The next graph is, again, a bounce at -12. So I will have f of x equals some value a and a bounce. So x plus 12 raised to the second power since I have a bounds. And then it will pass through the point 1 here, right here. That is the point 1. So times x minus 1. And then I have right here another point that it passes. Looks like it passes through the point 8. So x minus 8. Okay. Now, do you guys need me to figure out the a value here, or do you think you could do it by yourself? So I'm going to write this down again, the equation. So y is equal to some a value, x plus 12 squared times x minus 1 times x minus 8. You could see that we have all the intercepts that are matching. We just need to match our a value. So let's choose a point on this graph. What is this point here? This is the point -4, 2,304. That will definitely work. So let's choose -4, 2,304. Is there a value that I can see? I cannot see any other point here right now, so I will use this. All right, let's see how this one goes. So we're going to do the same thing. Maybe you want to pause the video here and try it yourself and see if you get the same answer as I do. This here's my x value. This is my y. I'm going to enter the values. So this value is entered for y is equal to sum a. X is -4, so -4 plus 12 is 8 squared. -4 minus 1 is -5. -4 minus 8 is -12. All right, so we have 2,304 is equal to 8 times 64, and -5 times -12 is 60. If we do 60 times 64, we will get 3,840 times a. Divide by 3,840, and that will work out to be 3/5. Okay, so a is equal to 3/5. Let's go back to the graph and enter 3/5 right here in the front. And we have matched our a value. Wonderful. All right, slide 29. The last one, pretty much. It says, what have we learned? Today you learned about how exponents on a factor change a graph's behavior at the root. But we also learned about the a value. So show how you know by writing the equation of the graph. So if I have a pass at x equals -4, that means I have a factor at x plus 4. So x plus 4. If I have a bend at x equals -1, that means I will have a degree 3. Or an odd degree, but in this case, most probably a degree 3. And then a bounce at x equals 4 would mean that I have a factor at x minus 4 that is repeated twice. Now you can always write it this way, x minus 4 twice. And I can also write this x minus 1 3 times, but this just saves us space. So I'm going to raise this to the second power, and this would complete this activity. Explain your thinking. So just repeat what basically we have learned and what it says here. And on the last slide, drag your point where you felt that this was totally interesting and it made sense, hopefully. But if it was confusing and it was interesting, so wherever you would like to put this point.